Hey everybody, how are we doing? It is one of the last office hours of the week. It got the sparkly green shirt. Oh my gosh, I'm disappearing with that green shirt. Let's see who's in the chat. Is Noel here? Noel, good to see you. Let's throw out some Mubot points. Mubot just woke up right there. I'm gonna make the chat bigger because I can't see anything. Have you done chapter 17 and 19? I think a lot of people have done chapter 17. Kaolin, good to see you, Kaolin. I've got a new poster for my whole place right here. We could do chapter 19 homework if people haven't done that. Chapter 19 homework, chapter 19 quiz. Maybe just do the full homework right now, right? Tell us how. I don't want to take your survey, Mount Pearson. I don't want to take the survey. A little chill music while we get going right here. Let's do the homework. There's a song in How I Met Your Mother like, let's go to the mall. What's her name sung it? Yeah, we could do the quiz too. Thanksgiving was good. We had a nice Thanksgiving. We didn't have any family over, so that's a bummer, but we're gonna have family over here in December. Big stuff going on, lots of family. Just we started playing Assassin's Creed Mirage, really good, really fun. I finished the homework. Yay! We'll review the homework and then we'll do some quiz questions. So get those quiz questions ready. Homework is due tomorrow. So we started playing a new video game because we beat Mario Odyssey. So we played Mario Odyssey, beat Mario Odyssey. Mario Odyssey was tons of fun. So really liked that. And I play Binding of Isaac all the time because I'm obsessed with it. Obsessed with Binding of Isaac. And yeah, I worked all Thanksgiving, didn't get to see my family. Oh, that's a bummer. I'm glad you'll get to see them coming up here soon. I think it's you need to value family, but then I think having a good mix, like we're gonna see actually we did see Chelsea's mom. We did see family. For Black Friday, her mom came up because they like to shop together, like, you know, like a mother-daughter thing, so they got to do that. So yeah, we did get to see family. I forgot. She came up for a little bit and said hey, and swung by, and Chelsea and her mom went out for Black Friday. So yeah, we did get to see family, so it was a nice day. So there's only 4 questions on the quiz. You're right, it's pretty short, and a lot of the questions follow the pattern. So if you can do the homework, I hope I'm not getting a cough again. Right when I start working out again, it's like, then you get sick. Then you're like, oh, got a little cold. So if you know how to do the homework, you can probably do the quiz. So we're gonna do the full homework. We're gonna show how to do it. And here we go. Stat 201, chapter 19, homework, question 1. Let's do it over here on the main screen. Okay, homework question 1. First off, you have to know how to write the null and the alternative. Do not look at their answers. Do not look at their answers. What is the one word when you do the chi-square test of independence that you put between it? It is pretty cold today. What is the one word you put between the two things right here? When this is how you memorize it for the test. Remember, we're preparing for the test right here. So if you're watching this, don't look at the Mount Pearson answers. Know how to do it for the test. When you do the null and alternative, what do you write for the chi-squared test of independence? It's called the chi-squared test of independence. So what do you write for the null? This is how you memorize how to do it. What do you do for the null? And sometimes they write a little bit differently, but we should always look for this. Well, the equal sign is for every other chapter except this chapter. For this chapter, we write that they are independent. So the null is that they are independent, and then the alternative is that they are not independent. So if you write the alternative, you'll simply add a not independent. Now, independent means that they are not associated. So to say two things are independent means that they have no relationship to each other. Like where somebody got injured and the lethality of it is independent, not associated. That's what it means. So you have to know synonymous words here. You have to know if we say they're independent, it means not associated. 'Cause sometimes my person will do that to you. But remember, it's the chi-squared test of independence. So when you look at the null hypothesis for the chi-squared test of independence, the null is that they're independent and the alternative is that they're not independent. Does that make sense, Noel, right there? When doing the chi-squared test of independence, the null hypothesis is that X and Y are independent of each other. I usually don't phrase it this way. I usually put the independent between them to say injury site and lethality are independent. So no, this is just practice, is memorization, getting ready for the test. Remember that we say injury site is independent of if it was lethal. The alternative is injury site is not independent of if it was lethal. So the lethality of it is independent of the injury site. Another way to phrase the null. The lethality of it is not independent of the lethality of the injury site is another way to say the alternative. So that's the null and the alternative. And now we need to find the expected values. Now this is way easier with jump. To do it with jump, so the answer is with, yeah, homogeneous. There's another test for homogeneity. Nope, those are automatically wrong. So you just be like, nope, we're doing the chi-squared test of independence, which the null hypothesis is that x and y are independent of each other. Like x is independent of y is the null. To do each one of these, I would suggest doing a little bit of them by hand right here. Does anyone know the formula to find an expected cell count? Does anyone know in the chat right here for points from Viewbot? I'll show you right here. What is the formula for the expected? That's row total. What is the formula for the expected? Does anyone know the formula in the chat? So I'm kind of writing it out for you right now. I am writing it out. You should know how to write this out. Ooh, pretty color. So the formula is column total times row total over grand total. So you would go here and go 118. You would times that by, and you do it for each one. You have to do it for each one of these. So notice right here, you would just fill this out, and then you would find what this equals. And this would be the expected cell count of very specifically this cell right here. If you notice how it crisscrosses into it. So that is the row total times column total over grand total. Row total, and since multiplication can be switched, you can switch it around. I would suggest trying to find a few of these because on the test we ask you to find them, so you won't be able to use jump. It's an easy formula. We give it to you, you just do this, and that's the expected cell count for that cell, 51.23. You can do it for all of them, you just have to change the numbers. It's going to be easier to put it all into jump and find it. And it's this top cell, I believe, 51.23. And it says to 2 decimals. I got this all wrong last time we were doing it. Might have been office hours or class, but I was getting every single one of these wrong. So the expected cell count for body fatal. Let's double check. And that is body fatal. That is correct. And you would just go through and move across like you would do, you'd move the 118 to 34, and that'd be body not fatal. And you can do them all by hand, but to do them in jump, make sure to pause the video right here. You want to go here to the data and copy the data. Copy to clipboard. And then hit Control-C or Command-C. Now go back into jump. Inside of jump, go to File, New, Data Table. File, New, Data Table. Once you go to File, New, Data Table, make sure to go here and go to Edit, Paste with Column Names. Edit, Paste with Column Names. Sometimes you don't have column names. This time we do. Once you paste with column names, then you need to go to Tables, Stack. Tables, Stack. Once you go to Tables Stack, only click the blue quantitative columns. Make sure they both exist right here. Now click OK. Now you can relabel these. You don't have to, but I usually do to relabel. This is a non-required step. You'll double click this column and you'll go and type your site and click Enter twice. Now you'll double click label, double click it, and then go and type outcome and then hit Enter. It just makes it a little easier to see what you're doing, and we might get it wrong, but I think we're trying to predict lethality, which makes it the Y variable of interest. We want to understand lethality, and does site of injury explain lethality? So we go here to Analyze, Fit Y by X. With Analyze Fit Y by X, remember what we said? Does site of injury explain why something is lethal, which is the outcome? You have to put data in here, which I almost forgot. So this is the way it should look. Unless I've reversed them, let's find out. Click OK. Now you can see the table down here and you see fatal body right there. So it looks like we've done it correctly. That was the cell we found. So with this output, we're going to go here and remove the total percent. We're just removing everything but count. And you can see the data that we have originally. We'll display it on the screen at the same time over here on the right side. So you can see this is the original data. And the counts of the observation are how many occurred. So the counts are what you see over there on this table. Those are all in the same order. So now we're going to remove the counts and put in the expected, which is the formula we just solved. And there you can see the value we got, 51.23 right there, which is the same value you see on the screen. Right there is that value for that cell. So then you want to take this information right here and just put it into the table. I'm going to move over to the other screen. You won't be able to see it, but you're literally just taking and putting, well, you know what I could do? Well, yeah, sure. You probably want to see it while I'm doing it. So let's do it. We'll go right here, take a screenshot, and then we'll go here, make this smaller for a second. And once again, I would suggest doing some of these by hand. And if you look at the, would this be correct for the value to calculate the cell for head and neck? Seems to be head neck. Well, it wouldn't be head neck. It'd be like neck fatal or neck not fatal. So the value you have right there, it might be for your table. Well, you wouldn't use 14 either. If you're using 14 right here, 47,118, because you always use the totals. You're either going to go 47,118 or 4734 for this column or this column. Does that make sense? The 14 won't be used right here because that's within the table itself. You only use the row totals, the column totals, and the grand total right here. Does that make sense, Noel? Really good questions, Noel, with 30 some points. Really good job. Make sure to know how to find these. Very important to be able to find them because we did it in Jump, but still know how to find these. So know how to find these. Yeah. Knowing how to find them is very important because on the test, you do have to find them by hand. It's just quicker and more accurate a lot of times to do it in Jump. But you could still just say, like you could say to me, Brian, like imagine I'm taking the test as I drop my pen on the ground for the 20th time. You say to me, Brian, I want you to figure out the expected cell count. You say, Brian, figure out the expected cell count of limb non-fatal. So limb non-fatal, I'll even show you my math for it. To do limb non-fatal, you'd go here and go limb non-fatal and divide by the grand total. So limb non-fatal is, move it away so you can see it, 34 times 39 divided by 152. So 8.72. And you go back here and you check your work and it was 8.72. Nice job. Nice job, Kaolin. Yeah, it's probably better practice to do it by hand. Now here's the not fun part. If you do that part by hand, it asks you for the chi-squared test statistic. And what you'll have to do right now is you'll have to get all the cell chi-squareds. To get all the cell chi-squareds, you have to do the following. So Kaolin, if you want to do this part by hand, great practice for the test. This is where there's a lot of work and we're basically showing what you need to do on the test. So really good practice. The formula for a cell chi-squared, is equal to observed minus expected squared over expected. On the right, I have the observed, and over here I have the expecteds, which we found via the formula row total times column total over grand total. So you need to find it for each one of these cells. Every single cell, there's 6 of them, you need to find this for. So the observed for the first cell is 60 minus the expected of 51.23, and then we take this quantity, square it, and do it by 51.23. It's about 8, so it's going to be like 1.3-ish, 1.3-ish, maybe. We'll find out. 60 minus 51.23, square that quantity. I said 1.3. Let's see how close I was. So it's 1.5. And what you would do is to track these is you would make a little table right here. So you'd go in here and make a little table just like this and track this top one is 1.5. And you probably want to carry that extra decimal or so, but you'd have to do this for all of them. You'd go to the next one. So the next value here is 14.76, and you'd do the same thing. So Kaolin, if you want to do this, it's not a bad idea. Like this is just good practice to see how to get cell chi-squareds. And then you'd put in the observed of 6, the observed 6, that's because the observed is over here. You go over to the expected, 14.76 and 14.76. That's a difference of about 9-ish. 9 is 81. This is going to be a big one. It's going to be about 5. No, it's going to be about 6 something. Okay. I always take a guess because if I take a guess and I'm way off, and then you can see how bad you were. Doesn't matter which way you subtract because you are squaring it. I said about 6, and it's about 5. Should win by 5 guess. So, and that's basically 5.2. So this is what you would do to get all the cell chi-squareds, which are a standardized metric of how far away these numbers are, because you're standardizing by the expected value. So you can do that and get all of them, but a quicker way of doing that, if you ever want to see all of them, is to just go right here and get the cell chi-squareds. So there's the cell chi-squareds, and they're also going to have more decimals carried. So if you notice right here, we put 1.5 and it's 1.4988. That's 5.2 because they're carrying every single decimal for us, and they did it for all the cells. So here's a test question. How do we get the Pearson chi-squared test statistic? This value down here, which is the Pearson chi-squared test statistic, how is this value obtained down here at the bottom? Very good test question, also on the Canvas contents. How is this value, the Pearson chi-squared test statistic, obtained? How is that value obtained? This is a very good test question. We asked this. How is that value obtained? Does anyone know? Write this down if you don't know it. It's another teaching the test moment. How do we get the Pearson chi-squared test statistic? How do we get it? If you say, I don't know, that's also points. You got it. You sum all the cell chi-squareds. So if you manually found all those cell chi-squareds, you'd go in here and start adding them. You go plus 1.4988 plus 1.54 plus 5.36 plus 8.750. This is why it's easier to do it, John, plus 30.3677. And there it is, 52 point, and we didn't carry all the decimals, but you add up all the cell chi-squareds, get the Pearson chi-squared test statistic. Remember, we go to my Pearson, easy way to remember which one we use. And it was 52.34 or something. Is that close enough? Nope. What did it want? It wanted 52.73. So we gotta make sure. There you go, right there. Fantastic. How many degrees of freedom does this have? You can look at JMP for this, but this is a formula we should all remember, and it is given on the test also. The degrees of freedom. Does anyone want to say how many degrees of freedom this has? This is a good memorization thing. How many degrees of freedom does this have? Does anyone want to say in the chat? Take a guess. I use some points anyways, but take a guess. It doesn't have 4. Good guess. You go rows minus 1 times columns minus 1. And the way to do this is to say, Brian, this is a 3 by 2. So what do you do to your fingers now? Not 3. Brian, this is a 3 by 2. So you delete 1 finger. What's the formula for so you figure out how many rows it has. These are the rows. You figure out how many columns it has. There's 3 here. There's 2 here. So how many degrees of freedom does it have? Another way to do it is to delete these and count how many there are. So yeah, and so how many degrees of freedom does it have? You are right. How many degrees of freedom does it have? 2. Because this is a 3, doesn't matter which way you multiply them, 2 by 3, 3 by 2. 3 by 2, delete, 1 times 2. So the formula comes out to, if you write the full thing, 3 minus 1 times 2 minus 1 equals 2 times 1 equals 2. I'm not playing that good. And as you can see, I deleted 1 row, 1 column, and that leaves the 2 inner cells, and there's 2 degrees of freedom. You can just count the cells then. A lot of ways of doing this. The more you practice it, the better you remember it, and you do get the formula on the test. Also, if you're confused, JMP does give the answer right there with the 2 degrees of freedom. No worries. That happens a lot. It's very common. And then find the p-value. I can tell you the p-value. It's 0. Because that chi-squared is crazy. So what you would need to do is, if you didn't have JMP to figure this out, you'd actually have to go to the chi-squared applet. And on the chi-squared applet, what would you do? The chi-squared has degrees of freedom on it, and you can see the chi-squared applet on the screen right here. And the first thing you do is you put in the degrees of freedom. We want to find a p-value using x, and notice 52 is not even on this curve. 52 would be way off this curve, so when you enter in the value of 52 point whatever, your p-value, what's really nice about this applet is you can actually get the decimals on it if you go to round, and you can see it's like 11 zeros before you even see your p-value. So it's a very, 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 very tiny p-value, basically 0, because we're way off the curve. We graph to the right on the chi-squared. It's a greater than test, And yeah, because we're looking for something unlikely by random chance or greater. So what do we do here? Do we reject the null or not reject the null? Look at the p-value. We don't really ask you to calculate a lot of p-values on the test. Yeah, we don't have you use applets on the test. We might have you look at a picture. And Noel's right. Since the p-value is low, reject the null. And always look at Canvas content. No one way to know what the test looks like, because then we're kind of giving you like, this is how we could ask it on the test, like all the theoretical stuff. We reject the null, so we reject, and this means we have evidence or we don't have evidence for the alternative. We have evidence for the alternative, we don't have evidence for the alternative. We reject the null, we have evidence or we don't have evidence for the alternative. We do not. If we do reject the null, we do have evidence, so we do conclude that they are not independent. Because the alternative was that they are not independent, so we can conclude and do have evidence that they are not independent. I do highly suggest knowing how to write this out right here. I think MuBot will tell us about the hypothesis test. So you should know how to write this out for the test. You would want to write the following. Let's show the completed version. I would write, I reject the null, that injury site and lethality are independent because my p-value is 0. And this is less than my value of alpha of 0.05. This means I do have evidence that the lethality of something is connected to or not independent of where somebody is injured. Does that make sense, Noel? I'll repeat it again. You can see what MuBot wrote in the chat. I do reject the null that lethality of an injury is independent of injury site because my p-value is 0. This is way lower than my alpha of 0.05. This means I do have evidence that the lethality of something is connected to or associated with the lethality, because remember, not independent means associated with. So try writing that out. Really good question right here. And a lot of these are very similar. If you can do that first one, the second one is, I think, nearly identical. Should we, like, let me see. I think it's literally the same. It's literally the same question. Just another practice, a little bigger, same sort of thing. If you did that last one, this second one is the same question. It's just the same sort of things. Oh, there we go. So here we'll do question 3. We might loop back. And Noel, if you have a question on the quiz, let's do the quiz question 2. But that first and second one are identical. So if you can do them, you can do the first, you can do the second. And these are the harder questions. This one's easy though. Okay. Suppose we conduct a test of independence and we end up rejecting the null. So what was the p-value if we ended up rejecting the null? This is a good knowledge question right here that I'm asking you beyond this question. If we rejected the null, then what was the p-value? If we rejected the null, what was the p-value? Good knowledge question. Good practice. If we rejected the null, what was the p-value? Anytime you reject the null, what was the p-value? The answer should be less than alpha. Less than alpha. I'm on top chat. I need to go to live chat. Well, so it'd be lower than alpha. Lower than alpha. So the p-value is lower than alpha. Like, depends on what the researcher sets alpha to. Alpha is the point at which they reject the null. If the p-value is lower than alpha, reject the null. A lot of times probably lower than 0.05, which is the default alpha. And alpha is just the point at which researchers say, I'm going to reject the null from here and below. So what would it mean if we rejected the null? I think there's kind of 2 right answers. Noel, you did pick one of them. Maybe I'm going to pick the wrong one. The wrong answer here would be B. The variables are independent is the null, which is what we've rejected. And they're maybe making it sound like there could be lurking variables. Maybe that's what they're getting at. So I think that's why they picked there's an association between the 2 variables. But I don't love this question, but it's a freebie because it's multiple choice and you can hit try again. If you miss it, you just go to try again. It's a freebie. Like if I remove it, it's just like a freebie question's gone. So yeah. What are the 4 conditions for the chi-square test of independence? What are the 4 conditions for the chi-square test of independence? So try right now to give me the 4 conditions in the chat for practice for yourself. What are the 4, which it doesn't ask that, but if you know that, you'll get this one right. What are the 4 conditions for the chi-squared test of independence? I'm going to put in here review 3, which is a great review to go to. Random, 10%, expected cell count frequency, and what's the last one? You are correct. MuBot loves that randomness right there. So random, 10%, expected cell count frequency, and then what is the last one? Random, 10%, all those points right there. Random, 10%, because you say those first every time, because they're the same. And then expected cell count frequency, at least 5 expected cell counts, which we can check via the formula. And last but not least, what is the last condition? Remember, go down here, a lot of great review. I'd highly suggest these review videos. I need to send out my review sheet. It is count data. You got it correct. It is count data. If you go here to the very end, you can see them all on the screen at the same time. And you can see chi-squared with 2 categorical variables, which is what count data condition is 2 categorical variables. You are correct. It is the count data condition, which means you have 2 categorical variables, which if you don't have that, you're not doing the chi-squared test of independence. The sample size is checked via what? A, B, or C. So Noel, with that answer, you should be able to know, how do we check that we have enough sample? Which is kind of what it's doing. Is it A, B, or C? It is A. And success failures for categorical data when we just have like one categorical variable, not for this type of data. Nearly normal is for quantitative data when we're doing the t-distribution, so the other answers are not the right answers. The degrees of freedom depends on what? We just did this a moment ago. Remember on the formula sheet, which we will look at right here, you do get the degrees of freedom's formulas. So what are the degrees of freedom? What are the degrees of freedom? Is it A, B, or C? What are the degrees of freedom? They're based on the what? Let's take a look. So remember, always have your formula sheet out and know your formula sheet. So when you look at your formula sheet right here, how many times have we used degrees of freedom in this class? Like how many different degrees of freedom formulas do we have? How many different degrees of freedom formulas do we have? So can you tell me how many different degrees of freedom formula are there? Oh, it's off the screen. Sure, let's do this, and now we got it. How many different degrees of freedom formula are there? There are 3 different degrees of freedom formula. I mean, we might be like use 6 times. It's possible there. So the 3 different ones are for the one sample t, what are the degrees of freedom? For the one sample t, what are the degrees of freedom? This is one easy to remember, easy mnemonic. For the one sample t, what are the degrees of freedom? I want you to tell me the formula. This is the first formula we learned for degrees of freedom, which tell you the shape of the t, if the t's flattened down, or if it's more normal, if it has more degrees of freedom or less degrees of freedom. The applet will do it for us. So what are the degrees of freedom for the one sample t, which means we're testing or making confidence interval for one mean? The degrees of freedom formula for the one sample t is what? How do you find the degrees of freedom? For the one sample t, degrees of freedom are, this is really good practice, n minus 1 right there, and that is the one sample mean, which means we're just doing one mean. That's why it's called one sample. If you wonder why we call it one sample t, it's because there's one mean. This is called the two sample t because we're doing the difference between the two means. And what is the formula? We're trying to analyze the true difference, so mu1 minus mu2, we're trying to analyze true difference. So what is the formula for the two sample t? What is the degrees of freedom formula for the two sample t? What is the degrees of freedom formula for the two sample t? Can you tell me the degrees of freedom formula for the two sample t? Does anyone know? There's a mnemonic for it. You've never heard me say this mnemonic. The degrees of freedom formula for the two sample t is too complicated. We don't solve it by hand. We've used applets for it. The degrees of freedom formula for the two sample t is too complicated. So you can go to one of our degrees of freedom calculator. Sometimes we just ask you on the test about it and be like, oh, it's a complicated formula that we won't solve by hand. And you can see right here, Mubot's about to put the link in the chat for the two sample t degrees of freedom formula calculator. And you have to go here and it just does the work for you with the two sample sizes. And you put in this and it's 198 because that's the maximum it can be. It's not always 198. If you have differing sample sizes and things like that, it won't be 198 or it won't be n minus 2 total n. It's a too complicated formula to review. The degrees of freedom formula for the two sample t is too complicated, so we will use jump output for it. The two sample t is too complicated. How about the degrees of freedom formula for a chi-squared test of independence? What is it? This is good review. The degrees of freedom formula for the chi, and it's right here on your sheet. What is the degrees of freedom formula? This is the cheat sheet or the notes sheet you get for the test. So what is the degrees of freedom formula for the chi-squared test of independence? What is the degrees of freedom formula for the chi-squared test of independence? Remember, you get all this info right here. You get this on the test. If you print it out or if you write it down, don't write down other things. Rows -1 times columns -1. Boom, right there. There's the degrees of freedom formula. Highlight degrees of freedom right there. It says degrees of freedom for the 1 sample t, 2 sample t, and chi-squared. So the rows and columns are the what's of a table. The rows and columns are the dimensions of a table. Like, what's its rows and column space? There you go. Got it. What it does. Okay, we got another one. This one is a little bit different. Noel, Kale, should we do this one or should we hop over to doing the quiz? So that's a really good review of degrees of freedom right there. And I try to make these videos more than just like, here's the answer to the question. So you get the answer, but I want you to understand it and know how to use your formula sheet. And you're like, yes, I can ace the test. Those memorization mnemonics can help. 1 sample t, n -1. 2 sample t, too complicated. Chi-squared, rows -1 times columns -1. If it's the same as the quiz, it might be. We'll do this one a little more quickly because it's very similar to question number 1. And so null hypothesis, put what between these? If we have to write out the null for this, we've got the age someone is and the outcome of their pregnancy are what? The age someone is, don't look at their answers, know how to do this without looking at multiple choice. The age someone is and the outcome of a pregnancy are what? Because we have age someone is. So the age someone is, really? They're independent. Boom. That's all you do. You just write independent between them. You can't erase that. You just put here independent is the null hypothesis, meaning that they're not related. Meaning if you knew someone's age, you wouldn't know how the pregnancy turns out. And there are things, and we know this is factual, that things like I guess certain complications occur more the older you are. Like, it's not like you will have it happen, but if we were to look at complications or certain issues that can occur, especially 40s, 50s. I don't know if anyone's got pregnant in the 60s, but people definitely got pregnant in the 40s and 50s, 99% certain. So we would have right here, age group and outcome are independent, is the null hypothesis that knowing someone's age would not give us information about the outcome of their pregnancy, versus the alternative, knowing someone's age would give us information, i.e. not independent. If something's not independent, it means it's related in some way. They just jump right to the chi-squared test statistic right here. So if you had to do this by hand, which you could, you would have to find all the expected counts. From all the expected counts, find all the cell chi-squareds, add up all the cell chi-squareds, and then get the Pearson chi-squared test statistic. So I would not do this by hand. But here's what's interesting. Let me look at these values. Oh, this might be a tough one. No, they look to be, that's about a 2.5, 2.5. It's going to be a low chi-squared. I'm going to go a chi-squared. I'm going to actually do this for real in a moment. 3 decimals. This is nearly very hard to guess. But I'll tell you why I'm doing this and showing this, because I was close-ish. I thought it was a small chi-squared because I looked at them and they looked about the same. What I was looking at here is that you don't really see if this is 2.5 more, it's just due to there's more late-term pregnancies, and this is 2.5-ish more, 2.5-ish, 2.5-ish. And that means because we have a low chi-squared, the p-value will be what? This is the theory you should know. Because the chi-squared is lower, the p-value will be water. We're just talking theory for a moment. I'm going to show you how to solve this. Since the chi-squared is lower, the p-value will be water. Since the chi-squared is lower, the p-value will be bigger. Does that make sense? Since the chi-squared, we don't know, around 4 digits. Since the chi-squared is lower, the p-value will be bigger. Does that make sense? Like, here's a bigger chi-squared, lower p-value because there's less area to the right of it. Lower chi-squared means bigger p-value. What is the smallest chi-squared can be? Type in the number that is the smallest value a chi-squared can be. What is the smallest value a chi-squared can be? Throw out some points. 0. Great job, Noel. You got it. And then the p-value is 1. So I can take guesses at this. I might be close. I might not be close. It's going to be about, what's 3 decimals? Okay, if I get this, that'd be awesome. Nope. So if I want to find the p-value, I have to know the what of the chi-squared first. If I want to find the p-value, I have to know the what, and we're going to find that chi-squared 2 in a moment. If I want to find the p-value, I have to know the what of the chi-squared distribution. Low chi-squared equals high p-value, correct. if I want to know, if I want to find this, I have to first find the what of the chi-squared distribution. Every chi-squared distribution has this with it. So if I want to find the p-value, I have to know this of the chi-squared. We were just talking about it a moment ago. It's the last question. The dimensions to find the what? You're right, Noel. The dimensions to find the what? I just found it right here. The answer is 3. I subtracted 1 row, 1 column, because this was a 4 by 2, which is 3 times 1. Right there. Degrees of freedom, yes. Degrees of freedom dictate the shape of the chi-squared. We put in here 3 degrees of freedom. You'll see the shape change. That's the shape of the chi-squared. So now we take the chi-squared test statistic of 2.468 and put it right here, and it graphs to the right of it. Notice the p-value is getting smaller, and it's 0.481. So we go right here, and we just enter in 0.481, and we get it correct. Does that make sense? I wasn't too close. It's hard to guess for small p-values. But does that make sense right there? You have to know the degrees of freedom, which tell you the shape, and then you graph to the right of the chi-squared you found. So you have to go to the right of that chi-squared you found. We'll find that chi-squared in a second. That's the hardest part of this question, the longest part. So what do? Don't look at their answers. Do we reject the null or not reject the null? Which is also said fail to reject a lot of times. Look at your p-value, reject or not reject the null. Don't look at their answers. Always think, what do you do before reading their answers? Do we reject the null or not reject the null? Reject, not reject in the chat. Type one of those two. Reject, not reject. Is it below 0.05? Is it? What's the p-value? But remember, 0.05, no, I think I see what you did. 0.05. Do you see it? Do you see it? You got it. I'm going to throw you some points. 0.05. 0.05. I see what you did. Because is that below 0.05? Nope. So the p-value is high, just let it fly. But also they're not using 0.05. They're using an alpha of 0.01, which it's way bigger than 0.01. So the p-value is definitely greater than 0.01. So they're going to not reject. So there isn't evidence. So you can see right here, the p-value is greater than 0.01. We do not have evidence to reject the null. Like that's how I would say it. Like if you look at what Mubot said a little while ago, we'll put it in the chat here again, how I would say this. If I'm writing this out, because you should know how to write it out, try saying it out loud. That's where you get real practice. Just read what Mubot has on the screen right here for the hypothesis test. I do not reject the null that someone's outcome of their pregnancy and their age group are independent because my p-value of 0.481 is greater than my alpha of 0.01. I do not have evidence that there is a relationship between these two variables. So, yep, that they're not independent. There we go. And we got the one thing wrong, so let's see how to do that. The thing that we missed, the null, is that they're independent. To do this part, it requires jump again or doing a lot of work by hand. I would highly suggest doing it in jump. You go right here and you go to copy to clipboard, and I'll pause right here. With copy to clipboard, hit Control C or Command C, and then go to jump, go to File, New, Data Table. File, New, Data Table. Under File, New Data Table, go to Edit, Paste with Column Names. Edit, Paste with Column Names. Now, go to Tables, Stack. Tables, Stack. Double-click both blue columns. Under Tables, Stack, double-click both blue columns. Click OK. Now, it doesn't really matter which way you do it because it's only asking for the chi-squared test statistic. Go here to Analyze Fit Y by X. With Analyze Fit Y by X, you can go and select the one categorical variable in the Y and the other categorical variable in the X and data in the frequency. The X and the Y have the same relationship as the Y and the X. For visualizations, it might matter which one you put where, but for testing purposes, the chi-squared will come out to the same value if you flip-flop them around. So in this instance, we're just finding the chi-squared, so let's go find that. Click OK right here, and make sure you put the data in there. Do you notice how this looks very flat? We still have this one open from earlier. This one had a chi-squared test statistic that was very large, denoting a big difference, where this one has a chi-squared test statistic that's very small, denoting small deviations that are likely by random chance. And chi-squareds might be close to this, 2.48. That's close to our last one. They might not have changed it up so much. Notice that this deviation right here, that the limb is a lot less likely to be fatal, and that's a big deviation telling you that there's an association, or we see likely an association. Like if I had to describe it, I would say it's better to get hit in the arm or the pinky than to get hit in the body or the head. And over here, you notice that the outcomes, or people having pregnancies, are about the same depending on their age group. The differences are very small and likely by random chance, i.e. the high p-value of 0.4774 right there. So these differences we see here are small, that's the chi-squared, and likely by random chance, high p-value. These differences are large, and hence big chi-squared. And when is it big? Well, when the p-value is small. So because this p-value is small, it tells us that these differences are unlikely by random chance, and they're big differences. What you might want to do, and I think we can add it in, if you were to interpret this, you'd often want to go here and enter in, well, I guess you had a graph builder, and you'd put in the percentages here. I thought you can put it in there, and you have to go to frequency here. I swear you can do it right there. I've done it. Yeah, don't doubt. There we go. And add, I could add in the percentages. That's percentage of, no, it is percent of the group. That's good. That's nice. Yeah, there you go. 73.5% of the injuries, or you can do this, you can hover over this and have it appear. That's the way I think that's what I was thinking about, or 60, ooh. Oh, I reversed it. Darn it. So you can go here to relaunch. Oh, and then here, I'll flip these, see if it does it. And then, very important. There we go. Now it's the same, but it's got the percentages on it. So that's good. That's a pretty good visualization, letting you see. Does that make sense, Noel? Where you can see that this is more associated, where the limb only had fatal injuries 36% of the time, probably gangrene or something like that, versus the most fatal spot to get hit would be the head. And this is where we think these differences are unlikely by random chance. We reject the null that they're independent, and we have evidence that there is an association. Versus this one over here, if we do the same sort of graphic with graph builder, we would get the following. We drop in the data, and we put in this. This is not required. It's just helping show the nature of what we're trying to learn. This will work right here. Well, let me reverse it. Undo. So column 1 should go on the left. Okay, column 1 will go here, and then label will go there, and then data will go in frequency, and then we'll go here, and then we'll add in the percentages, and you can see right here. So now if you look at this graphic where the percentages are virtually identical, those are tiny percentages, not going to show us, oh man, look at that, 2.7% in there and 2.9% in there, 2.8, and the differences are very small and likely by random chance. So the differences here are small and likely by random chance. The differences over here are large and unlikely by random chance, given that there is no association. So it was something like 4.2, well, that's that one, 2.488, 2.488. So 2.48. Oh, 88, really? Really? Oh, there we go, 2.488. That's mean. And then the p-value was 0.4774, 3 decimals. And then because the p-value is high, we do not reject the null. It's way greater than our alpha level of 0.01. The p-value is greater than the level of significance. There is insignificant evidence to reject the null. We've done it. Any questions? The questions are very similar. A lot of these can be done, I think, best using JMP, but then you should know the theory behind it and how to work them by hand. And we did a lot of the chapter right now. We didn't really talk about the expected cell count greater than 5, but this is a good review of the chapter. Like, we've done all the questions mainly. Go over this type of question one time for the quiz. Basically, I just want to make sure. Yeah, definitely. Well, let's see right here. Do one of the quiz ones. Let's see. Are sirens outside? What's going on? What's going on with the world today? Lots going on. Always the way it is, right? I really think, always think about taking care of others and yourself. Take care of yourself first, not in a like selfish way, but it's kind of like the airplane way. Like, you know, like you put on your mask first when you're on the airplane, and then you help someone beside you. I think that means we need to be in a healthy state of mind. When I say take care of yourself, like get good sleep, get good food, get good socialization, things like that. And from there, you will do this one because we haven't done it. From there, you have the ability to help others. So if you're in an unhealthy state of mind, you often don't have the ability to help others. So if you optimize yourself, you can optimize your helping of others. That's the way it goes. It's Life Advice with Brian. The sirens have been so bad the last 3 days. I woke up to that. Oh my gosh, 3 fire trucks. I'm so sorry to hear that, Kellen. I saw one at the University Center this morning. I hope everything's all right. I need to go and check on a person that I care about. Just make sure they're all right. I don't know. Just hate thinking something bad happened to someone. And hopefully whoever that was is all right. Okay. Here we go with this question. What's the null hypothesis? Nice and easy. Just put what between them. Null hypothesis, put what between them. You can do it. You got this. What is the null hypothesis? Just put what between them. You see this right here? You've got someone's region and political affiliation. What do you, Maris, the chi-squared test of independence with 2 categorical variables with count data condition. Null hypothesis is going to be that they're independent. Oh, look at what they're doing right here. The alternative is that they're not independent. So, be the null. Now, they're jumping right to the chi-squared, and you don't get to guess around on this one a lot, so you need to figure out what the chi-squared is. What is the easy way to do this? The easy way to do this is put it in jump. Check out the earlier questions if you jumped right to this one. We went a lot through it. I might try to do 2 today or 2 more of these for today. But we're going to go here to copy to clipboard. Boop. Hit Command-C or Control-C, Mac versus PC. Go down here to jump, and you can see all the work we've been doing. And on jump, you can click anywhere you've been working and go to File, New, Data Table. File, New, Data Table. Under File, New Data Table, you need to paste with column names. Don't just hit Control-V or Command-V. Paste with column names. And if you don't do this, restart your data table, because I see a lot of people do things like this, and then they're trying to fix it, and it doesn't work. Just be very careful. Make sure to paste with column names, and just open up a new data sheet, Control-N or File, New Data Table, and just make sure it looks like this. Make sure it's red, blue, blue, blue. Once you get the red, blue, blue, blue here, which I'm talking about this right over here, it should look like this. Go to Tables, and then go to Stack. Tables, Stack. Under Table Stack, click only the blue columns right here, and it will stack them up for you. Once you've stacked them, click OK. Now, I'm going to double click and change this. So it's called Party. And I'm going to double click and change this and call it Region. It actually doesn't matter, but it just looks more pretty. Rock knows. It doesn't really matter. We're going to go here and then go to Analyze Fit Y by X. With Analyze Fit Y by X, we're going to put in, does somebody's region of the United States explain their party? And we'll put the data in right here. And now, if you think about this, do you think there's an association between the region of the US you're in and the party you're associated with? Yeah. And this isn't talking politics, it's just what we know about the world. If I say there's someone from California, exactly, Noel, exactly. If I say there's someone from California and there's someone from Oklahoma, who do you think is more likely to be a Republican? You would say the person from Oklahoma. I think Oklahoma is one of the most red states I think there is. We'd say red and blue in the United States. Red means Republican, blue means Democrats, just the way we decide on these things, because we got a red, white, and blue. Who's has it got red, white, and blue? I don't know. And then we got the Green Party. Why don't we got like the purple? I don't know. I'm just coming up with things. So it doesn't mean someone is a certain party if they're from this area. It just means that they're more likely. And once again, statistics is about trends in data and trying to understand likelihood of things occurring, not that things will occur, but do we see an association? Let's go ahead and click OK right here, and the test has been done for us. If you're talking about, and I do think this is a bit odd the way it's shaded, this is not required, but I'm going to go here to set colors, and we're going to click on this, and we're going to go to red, and we're going to go here, and we're going to go to blue, and we're going to click OK, and now it looks more like you would expect in the United States. Not required, it just makes it easier to understand that in the West, apparently, there are more Democrats. You probably didn't know this, but in the North, there's more Republicans. They're just making up their own data. I wish they used real data, but usually in the North is more liberal. Not always, not every state, not always. But you say, I know someone from the North and there's someone from the South. Who do you think is Republican? You might be wrong, you might be right, but there's likelihoods with these things. And apparently they're saying the West is really where the Democrats are at. Maybe California, I guess, something, at least with the way the real data is. And the South, apparently, it's just weird. The North should be, we can make our own data for this. But we need the values. Before I go and make up our own data for this, we're going to go right here and take this chi-squared, Pearson chi-squared test statistics 7.733, and that is this value all the way back here, and it was 7.733, and this was 0.102, And because the p-value's low, whoa. The p-value's high, just let the null fly. So the p-value's high. I'm gonna take off the hoodie real quick. P-value high, let the null fly. So the p-value is high. We let the null fly, which means we do not have evidence for the alternative. Get hot in here. P-value high, just let the null fly. We do not have evidence for alternative. So p-value high, just let the null fly. Fail to reject the null. We failed to reject the null. There is not evidence for the alternative. Oh, wait. Check answer. Should be right. Oh my gosh, my computer's crashing now. What in the world? What? Just everything. Oh. Everything. Craziness. That was a good question. Sample size, check with expected cell count. Good stuff right there. Degrees free and depend on the dimension. I think we've done basically every question. It's like these are the same questions right here that we've already done. And then this one we did earlier. We've literally done. And then this one right here is just another chi-squared. What do you think? I'm just kind of burning through them now because you know where to click. This quiz is pretty easy. That's why I'm like, no, do it, but learn the concepts. We did the concepts a lot quicker before, or a lot slower. Now we're doing them quickly. Chi-squared for my table is 4.268. Three values, 0.234. That p-value is way greater than p-value greater. There's insufficient evidence. The null is that they are the same. They're independent. The alternative is that they're not independent. There we go. And there's my there's the p-value. There's the chi-squared right there. P-value chi-squared, and that's that one. And then this one is just so crazy. It's so much to enter in. Why we don't select the red and jump for the type of question? Oh, just for stacking. It's just the way it goes for stacking data. You're just stacking the quantitative columns. Good questions, Noel, right there. You're just stacking the quantitative columns. And these are the same ones we did earlier. That was the first question. You're just stacking the quantitative columns. Make sure to stack only the quantitative ones. Only... yeah, I got done that. All the quantitative ones. There we go. Well, good stuff. Pink undergrad B school. Yes. Awesome. Well, I'm gonna start getting ready for class. Until then, bye for now, everyone. Bye. Almost done.